So good day, saints and lovers of STEM. I'm here to share with you the latest updates with my flower bots, robotics for the streets, open source robotics for academics, K through 12 teachers, any kind of STEM enthusiast, as well as corporate America or researchers. So we have LilyBots, our smallest robot, which has a 6-inch diameter and most appropriate for 3rd through 12th grade or maybe freshmen in college. Then we have our DaisyBot, which has a 9-inch diameter and may be more appropriate for middle school to high school or maybe even undergraduates in college. And then RosieBot, which we are working on to be for our research platform for more advanced undergraduate or graduate students in robotics. All of them are programmed with either an Arduino Uno or Arduino Mega. This week, I have discovered a great new resource for K through 12 teachers that want to use LilyBots, and that's graphical programming. And today I'm going to show you how to use graphical programming to read a sonar sensor and to trigger LEDs based upon the distance of an object or obstacle from the robot. Please come along and enjoy. So here's our EduKit screen, and the first thing we're going to do is to create two functions. The first one is get distance, which is used to read the sonar sensor. So we set a trigger pin high, wait 10 microseconds, then set that same trigger pin low. Then this is like our pulse in function that is waiting for that pin to go high, which represents that it has received an echo back from the sonar sensor. Then it returns that time, and we divide that by 148 in order to get the distance back in inches. So once we have this value, we then use it to make decisions about which LEDs to turn on and off. So next, we have all LEDs off, and all this function does is every time it cycles through the loop, it turns all the LEDs off so that we can read them again. So now we'll go to our setup function. In our setup function, we define all of our variables. So we have a yellow, red, blue, and green LED on pins 10, 11, 12, and 13. The echo pin is on 18 and the trigger pin is on 19. Note that 18 is A4, analog 4 pin, and 19 is the A5 analog pin. Then in the loop forever, we're going to read our get distance, and if it's less than 4 inches, turn on the yellow LED. If it's less than 7 inches, turn on the red LED. Less than 10 inches, turn on the blue LED. And if it's greater than 10, the green LED should be on all the time. And then every half second, all the LEDs turn off and it cycles through to do it again. So the great thing that I like about this software is that as you're writing your code, it's also generating the Arduino sketch code that I can then upload to my IDE to upload to the robot. So over here is the code that was generated by CodeKit. Notice that it made integers, yellow, red, trigger, blue, green, LED, and echo, and it made two floats variables, distance and echo time. Then here's my get distance function, which digital writes the trigger high and low with a 10 microsecond delay in between. And then here's where it returns the distance, which is the echo time divided by 148. Then here's my all LEDs off function. Down here's my setup function where it sets the LEDs as outputs. It defines the pin connection for the LEDs, as well as the echo and the trig. And then it defines the pin mode for trig as an output as well. Then finally down here is my loop where it gets the distance and turns the LEDs on and off. Let's see what this looks like on the robot. Okay, so here we have our robot with the 4 LEDs, green, blue, red, and yellow, and the front sonar is connected. So what happens is when there's nothing detected, the green LED blinks as it is now. Then when I put my hand in front of it, like red light, green light, blue light, the colors will change by how far away my hand is. So when I first put my hand down, you can see the yellow. It's a little dim, but there's our yellow. And then as I move my hand back, it changes to red. So I'm right on the line. So there we go. And there's red. Then if I move my hand back some more, it changes to blue. Then if I remove my hand, it changes to green. So this shows us a proof of concept that the sonar's working. If you wanted to connect all 4, you could then do 360-degree obstacle avoidance. So if the robot's driving forward, you can just do front obstacle avoidance.